General relativity, step by step. I've been considering the Einstein field equations and I've reduced them, well, I've transformed them into this scalar form here. And I'm going to use that to recast the Einstein field equations, which I'll rewrite for convenience. Minus a half fundamental tensor alpha beta times the Ricci scalar r plus cosmological constant times g alpha beta equals k t alpha beta. And you'll recall that k, we don't know what that is. It's a scalar and I'm just trying to pin it down. So what I'm going to do is to use this equation here and substitute for the value of the Ricci tensor there. R alpha beta minus a half g alpha beta times r, which is 4 cosmological constants, this is on the other side, minus k scalar t, plus cosmological constant times alpha beta, equals this k t alpha beta, and we'll see how this equation works out. What I want is an expression for r alpha beta equals, well, everything else. What does the Ricci tensor equal? You'll notice I've eliminated the Ricci scalar, so it should make things a little bit easier. Well, how many cosmological constants have I got? Well, I've got 4 times minus a half is minus 2, plus 1 is minus 1, so I've got a whole 1 cosmological constant on the right-hand side, plus what? So I've accounted for that term and that term there. This is on the right-hand side of the equation, so it's kt alpha beta, which is this term here. And now we've got plus a half g alpha beta kt. So that's a minus, because minus and minus is a plus, and we're on the other side, which is a negative. The half hasn't changed. G alpha beta times k times t. And of course I'm just going to factorise that. Cosmological constant g alpha beta plus k, and I still don't know the value of k, times t alpha beta minus a half g alpha beta times the stress energy scalar t. And that is equal to the Ricci tensor r alpha beta. This is an alternative form for the Einstein field equations. It's more useful in practice when you're actually trying to solve the equations, because very often you want to know what the curvature tensor is so that you can set up a sensible coordinate system. As opposed to the original form, or the more commonly seen form, I guess, which is this form here. I guess you could call this form the mathematician's form, and this form here is the physicist's form. Although that distinction doesn't really bear close scrutiny. Anyhow, it's another form of the Einstein field equations. Still unknown up to a value of up to the value of k, which is an unknown, at this point, unknown scalar, which I'll derive over the next few screencasts. Stop there. Stop.